a can of your favorite soda, a fluffy towel, even the smartphone you're holding right now. Here on Earth, they're just part of your day. They're harmless, simple, and you probably don't think twice about them. But what if the most ordinary things in your house could become deadly? Because in the unforgiving vacuum of space, they absolutely can. The laws of physics that keep you safe and sound on Earth get completely rewritten up there. In the void, the cold, and the weightlessness, everyday objects transform into instruments of chaos, capable of crippling a multi-billion-dollar spacecraft. Or worse. Today, we're counting down the 10 everyday objects that would kill you in space. We're starting our countdown with something you've probably eaten this week, maybe even this morning, a simple slice of bread. On Earth, it's the foundation of a sandwich, a piece of toast, a humble staple. In space, it's a floating menace. Why? One word: crumbs. In microgravity, crumbs don't fall to the floor. Instead, they float, creating a cloud of abrasive particles that gets into everything. An astronaut could inhale them, leading to choking or lung damage. But the danger doesn't stop there. These floating specks can drift into the sensitive electronics that keep the space station running. They can clog air filters, short-circuit instrument panels, and even become a fire hazard. And this isn't just a theory. During the Gemini 3 mission back in 1965, astronaut John Young famously smuggled a corned beef sandwich on board. When he took a bite, crumbs immediately started floating through the capsule, creating such a hazard that he had to put it away fast. This is exactly why bread is banned on the International Space Station. Astronauts use tortillas instead. They don't crumble, making them a much safer way to have a sandwich in orbit. Next up, at number 9, is that can of deodorant, hairspray, or air freshener you have in your bathroom. On Earth, it's just a convenient pressurized container. In the vacuum of space, it's a potential bomb. Aerosol cans work because the pressure inside is way higher than the air pressure outside. When you press the nozzle, that difference in pressure forces the product out. Now, imagine taking that can and putting it in a vacuum, where the outside pressure drops to basically zero. The pressure difference becomes enormous, putting an incredible amount of stress on the can's metal walls. The can could rupture violently, exploding and sending sharp metal fragments flying in every direction. In a tiny space like a capsule, those bits of shrapnel become lethal projectiles, easily puncturing the hull, destroying critical equipment, or injuring an astronaut. On top of that, the propellants in many aerosol cans, like propane, are highly flammable. Releasing them into the oxygen-rich air of a space station would create a huge fire risk. For all these reasons, you won't find any standard aerosol cans on the ISS. Continuing our list at number 8 is the simple glass bottle. Whether it's holding a soda or your favorite hot sauce, on Earth, it's a sturdy, recyclable container. In space, it's a floating disaster waiting to happen. The main danger here is pretty obvious: breaking it. In microgravity, if you drop something, it doesn't just hit the floor. It keeps going until it hits a wall, a window, or someone's face. A dropped glass bottle would easily shatter on impact. But unlike on Earth, the broken pieces wouldn't fall. They'd scatter in all directions, creating a cloud of razor-sharp floating daggers. It would be almost impossible to clean up every single tiny shard, leaving a permanent hazard that could tear a spacesuit, sever wires, or cause a serious injury. And that's before we even talk about the liquid inside. It wouldn't spill downwards. It would form floating blobs that could contaminate surfaces and short out vital electronics. The combination of floating glass and rogue liquids makes glass containers an absolute no-go for space travel. At number 7 is an object so common it became the star of a famous space race urban legend, the ballpoint pen. The story goes that NASA spent millions developing a pen to write in space while the Soviets just used a pencil. The reality is a bit more complicated, and it shows why a regular pen is useless and a pencil is downright dangerous. A standard ballpoint pen depends on gravity to work. Gravity pulls the ink down onto the tiny ball at the tip, which then rolls it onto the paper. In the microgravity of space, there's no down. While some ink might flow for a bit due to capillary action, the pen is completely unreliable for any real use. So, why not just use a pencil like the cosmonauts did? Well, pencils have their own deadly flaw. The tip can break off, and sharpening creates wood shavings. Just like breadcrumbs, tiny flakes of graphite and wood would float through the cabin. And graphite is conductive, meaning it can short-circuit electronics. It's also flammable, and you don't want to breathe it in. This is why the Fisher Space Pen was eventually adopted by both sides. It uses a pressurized ink cartridge that forces ink to the tip, so it works in any direction and, most importantly, creates zero hazardous debris. Number 6 on our list is something you use to dry off or clean up: a towel. How could something so soft and simple be a threat? The danger isn't the towel itself, but what happens when it's wet in space. If you wring out a wet towel on Earth, water drips to the floor. In space, something totally different and bizarre happens. Canadian astronaut Chris Hadfield actually demonstrated this on the ISS. When he wrung out a wet washcloth, the water had nowhere to go. Thanks to surface tension, it just clung to the towel and his hands, forming a strange, gelatinous sleeve of water that just floated there. While it looks cool, this is incredibly dangerous. A big free-floating blob of water could easily drift into an electrical panel and cause a catastrophic short circuit, maybe even a fire. It could also be inhaled, creating a serious drowning risk in an environment where you can't just cough the water out and let it fall away. Because of this, astronauts use special soaps and carefully managed amounts of water on their towels, making sure no stray droplets can escape. We're halfway through our list, and the dangers are only getting stranger. It's wild to think about how just removing gravity turns our world completely upside down. If you're finding this as mind-blowing as we are, do us a favor and hit that subscribe button and ring the notification bell. That way, you won't miss out as we explore more of the craziest science in the universe. Now, let's get to our top 5. At number 5 is the very device you might be watching this on right now: your smartphone. You take it everywhere, but if you took it to space, it would be a ticking time bomb. The danger is something invisible and relentless: space radiation. Down here, Earth's atmosphere and magnetic field act like a giant shield, protecting us from the worst cosmic rays and high-energy particles. Out in space, that shield is gone. These particles can blast right through a device and flip the ones and zeros in its memory. This is called a single event upset, and it can cause your software to crash or your data to get corrupted. Even worse, a high-energy particle can cause permanent damage by creating a short that draws huge amounts of power. This could cause the device to overheat, its battery to fail, and potentially even release toxic chemicals from its internal parts. Electronics built for space are radiation-hardened, meaning they're specially shielded and manufactured to resist this damage. Your off-the-shelf smartphone, on the other hand, would be a sitting duck. Coming in at number 4 is something you use to keep your home clean: a bottle of cleaning solvent, or disinfectant wipes. In the perfectly sealed environment of a spacecraft, these seemingly helpful products can become a source of toxic contamination. On Earth, when you use a strong chemical cleaner, the fumes just spread out into your home and the outside world. The International Space Station, however, is a closed loop. Every single bit of air is recycled over and over again. This means that chemicals released into the air don't go away. They just build up over time. Studies of the dust on the ISS have found higher than normal concentrations of chemicals used in everyday cleaning supplies. Breathing these in day after day can lead to eye and lung irritation, or worse. A major leak of a volatile chemical could quickly make the station's atmosphere toxic. This is why every single item brought to space is rigorously tested for off-gassing, the slow release of vapors, to make sure the air stays safe to breathe. Breaking into our top 3 is a simple pleasure many of us enjoy every day: a can of soda. Carbonated drinks are banned on the ISS because in space, they're not just messy, they're physically miserable. The problem, again, is microgravity. On Earth, when you open a can of soda, the carbon dioxide bubbles are lighter than the liquid, so they rise to the top and escape. In your stomach, the gas also separates from the liquid, which lets you release it with a simple burp. In space, none of that happens. There's no buoyancy, no up for the gas to go. The CO2 bubbles stay mixed in with the liquid, so when you open the can, you get a foamy mess as the gas and liquid erupt out together. And if you tried to drink it, you'd be swallowing that same foamy mixture. In your stomach, the gas still won't separate properly. This leads to a very unpleasant condition called wet burping, where trying to burp brings up not just gas, but a spray of foamy soda. It's a guaranteed recipe for acid reflux and a huge mess, making fizzy drinks a definite no-go. Our runner-up for the deadliest everyday object in space is something you might have stuck on your fridge right now: a magnet. And while a small decorative magnet isn't a huge risk, any powerful magnet brought into a spacecraft poses a silent, invisible threat to the entire mission. Spacecraft are packed with incredibly sensitive electronics, and a lot of that equipment relies on precise magnetic readings to know where it is and where it's pointed. A ship's magnetometers, for example, measure Earth's magnetic field to help determine its orientation. Bringing a strong, unaccounted-for magnet on board is like trying to use a compass right next to a giant electromagnet. It completely throws off the readings. This could mess up the pointing of communication antennas, the alignment of solar panels, or the accuracy of scientific instruments. The risk is so serious that NASA has strict magnetic cleanliness protocols, where all equipment is checked to make sure it hasn't been accidentally magnetized before launch. One stray magnet could send the whole mission spinning off course. And the #1 most dangerous everyday object in space is probably the most obvious, but also the most terrifying: a simple match or lighter. Fire in space is an astronaut's absolute worst nightmare, because it behaves in ways that are completely alien and far deadlier than on Earth. Here on the ground, gravity is a key ingredient for fire. It pulls cold, dense air to the bottom of a flame while the hot, lighter gases rise up. This convection creates the familiar teardrop shape and constantly feeds the fire with fresh oxygen. In microgravity, there is no up for hot air to rise to. A flame becomes a silent, slow-burning sphere. It doesn't flicker. It just sits there. Oxygen molecules have to slowly drift into it, which means the flame can burn at a much lower temperature, making it harder to detect. Even scarier, experiments have shown that cool flames can exist in space. They're nearly invisible and can seem to go out, only to reignite later. In the closed, oxygen-rich environment of a spacecraft, an uncontrolled fire would spread unpredictably and fill the cabin with toxic smoke, leaving the crew with nowhere to run. From breadcrumbs to bubbles, the simple laws of physics we rely on every day become life-or-death challenges in space. Every single object sent into orbit has to be re-examined for dangers we would never even think about down here. The fact that astronauts live and work safely in that environment is a huge testament to their courage and to the incredible minds that figured out how to tame these seemingly ordinary, but potentially lethal, objects. It really makes you realize that even the simplest things are way more complex than they seem. Did you think these everyday objects could be dangerous in space? Let me know in the comments. And don't forget to like and subscribe for more videos.